This is great to be here. I think this is one of the funnest conferences that I go to every year. And this is actually, I think, maybe the fourth time I'm presenting something on zones and conduits. So 62443 is getting implemented somewhere, just so everybody knows. But I kind of want to talk about why I'm actually presenting this topic. And in our organization, and like many of your organizations, we have technology-specific people that support operational technologies and information technologies from the center of our organization. And those people are starting to get, I guess, a little bit aware or a little bit smarter, and they're starting to say, I think some of those operational technologies are actually more like IT. Like we can support them more like IT. And just to give you some background, in our organization, we kind of have a responsibility delineation between what an OT system is and what an IT system is. And it gives us different authorization. It gives us different what we call functional authority. And that usually takes place between the DMZ and the business network. And so they're looking at it and now they're saying, can we go ahead and move some of those DMZ servers, for example, into the cloud? And so this is kind of a transition. We're trying to see what would take place there. My team is an infrastructure security team. So we look at the servers, we look at the virtualized systems, we look at the network equipment. And then we also look at the tools that we have to help make these types of decisions. We're not a decision authority, but we make these types of decisions. We can help make these types of decisions. And one of those tools is like the zones and conduits kind of philosophy and model. And so we're not a roadblock, we want to help them through it, but we start by saying, let's see if this works. That was smooth. We start by saying, should we move it? And then so we look for some rules to help us determine if we should move something to the cloud. And some of those rules are like the security, the foundational, and the other security requirements that are in 62443. And so what I'm leveraging today is 62443 3-3, and where the rules might not allow us, or the security requirements might not allow us to move something into the cloud based off of the risk of the system, right? So let's see if we can continue this on. Okay, one thing that I think I have to point out, I'm trying to figure out what would happen if we move some of these systems into the cloud. We cannot slow down progress. If there's anything that we've learned is that technology is always going to pull us along. If it didn't, we would still be the gears in the machine. We would be the cogs in the machine, but we're not. Things have changed over time, and the pavement is already there. The tracks have been laid, and even mid-90s and early 2000s, most of the software that supports these solutions is cloud ready, I could say. And we saw this with Web 2.0 when a lot of stuff, before it was even really called the cloud, started moving to application connectivity and connections and application level security even. And that's really where we see our APIs coming from, for example. The application controls everything. And if you saw a presentation earlier in the fireside chat about OPC UA, that's one of the modes to help us manage that connectivity. We're kind of in this space. I think some people are saying, oh, you can't connect things to the internet, you have to disconnect it from the internet. And the definitions behind what the internet exactly is and what those connections exactly are is really, really vague. So what I just want to point out is eventually, we are going to go, as an industry, as a world, we are going to go to this place where most of this stuff can be automated. Over the last 10 years, there's been a cloud-first mentality that's starting to push its way into OT, and it will. And now there's an AI-first mentality. And so the people who are driving AI, if they drive your cybersecurity programs, are going to be driving you to implement AI, and they're going to say, why can't I have this in the cloud so I can use my same AI models for OT? I'm going to go through some of this stuff pretty quickly so I don't run out of time. This model here is actually from 62443 1-1, and this is like, I think, figure 15. But the idea is this is what a SCADA system looks like. I don't need to go into detail about that, but there are different parts of this system. And if you're expecting boxes and lines connecting the boxes, then you're not going to get that in here, because that's not really what zones and conduits is all about. In this model, what we're talking about is where does the security requirement or the risk-based security decision get made? According to 62443, if objects have the same security requirements and they also need to be connected for functionality reasons, they end up in the same zone. Now here, we use a safety-based process, and we determine that all of these are going to end up in the same zone, essentially, and there's probably no security in between the controllers and everything down, lower in the Purdue level. In this example, the remote connections are actually in the same security level as well. There's no additional security that's needed there. And then the SCADA system has the same security because it actually can cause the same impacts, if misused, that could happen out in the field. Now, there's a translation that takes place in the DMZ, and then the enterprise, there should be no, what I would call, control system technologies in the enterprise. That's the philosophy. There's no control system, so you don't need an SL. Some people might not agree with me there, but you have a different process for that. Now, this is also a knowledge transfer session. So before I built this out and drew this out, I thought, I should get down into the weeds, but I can't do that in the time slot that we have. So what I want to do is I want to use a reference. This is NIST cloud architecture from 500-292 of what a cloud architecture actually looks like. So here we have our physical connections to the data center, to that cloud environment from the internet or from whatever connection they have. That's the only physical connection. So if you think of conduits like a physical connection, you start to lose track of where your conduits are. And then instead of that pancake kind of stack, it's just an environment of software. So the only physical hardware is the actual servers that are mounted in the racks in the thousands of data centers that are getting deployed across the globe. The first level of software is that resource abstraction level. And in that level, it's not a level like you would think of a network architecture. It's actually just the virtualization of the hardware that's in the data center. And then there's an application level where you as a user actually logs in. So that's where you have the first level of control, I would say, in your cloud environment. But it's based off of what you have access to, your subscriptions and so on. And then you can build out infrastructure. You can build out platforms, which is how you manage containers. And then you could also build out applications, or other people could build out applications, like some of you that sell software as a service applications to us. Now, this physical area here, this is the only connection. And we have no control over that connection, so you can't think of this as a conduit, right? This area right here, somebody has godlike permissions over that, but if they're providing that to you as a service, you're not going to have permissions over that. You've basically delegated functional and security authority to them. Infrastructure, you could build out a virtual data center, and I think some companies are going, it might be nice to kind of lift and shift to the cloud. This is how we would do it. But then you're also not taking full advantage of cloud. Just by moving stuff to the cloud, you still have to patch it and all that. And platform as a service, you'll never have control over the directory services and the operating system or any of that kind of stuff, but you can kind of manage some of your software and your applications. Software as a service, usually the only access you have is your user account, right? Now you can manage the stuff too, but you still are at the mercy. So the cloud service provider owns all of this. The infrastructure, you can own that, but think of it like a virtual data center. You still have to manage it. Probably not going to be where you use it. Platform as a service, you can have control over that, but you don't have control over the servers. And then software as a service, you could have your software, but that would be something that you deploy in your platform, and then software as a service. So just at this point, this is more of a knowledge transfer. I'm just showing you the simplified view of what a cloud environment actually looks like. Where would you put your zones and conduits architecture in the cloud? Just by looking at this, would it be a software application? Would it be a container? Would it be virtual servers and routers? And so that's why we have to look at it a little bit differently than what we look at zones and conduit as today. And I would say the standard hasn't caught up to it yet. I know there's a new release coming out for 1-6, which is for IoT, and we've had discussions about a subsequent cloud white paper case study or something coming out that could be part of the standard, but that's a little bit further in the future, and that hasn't really been developed yet. So zones and conduits doesn't account for this environment. It's all software security. It's all software security. And that kind of confuses a lot of people in the OT security space. I'm going to give you 2 zone examples just to kind of keep this in the zone and conduit mode. I could come up with more, but we're going to just do 2 here. And these are the most common that I see today. The first one is the cloud sensor. You could call this the industrial Internet of Things. I got to the point to where the subtext at the bottom of the slides was getting to be too much, and it wouldn't make it through my corporate affairs department. So enterprise connections, there's something that takes place to get it on the backhaul all the way up to the internet, the cloud provider, and then all that cloud stuff in between. And finally, when you sell that one sensor with the cloud service to the client, what you're seeing is, oh, it's got security, secure by design was built into it, but you're seeing one device and you're seeing one application, user interface on the application. You have to figure out what the architecture looks like from the device all the way back up to the application. And so what I'm doing here is I'm kind of redefining what a zone looks like. There's a hardware component, there's a physical connection component, and we see this already in our existing environments, but there's also that software and software connection component. So there's the physical connections. You need to find an open network, or you need to deploy an open network, or figure out a way to use an open network for the sensors to connect to. And you want it to be universal, so you don't want it to be you don't want it to be in your existing network and connected to your existing control systems that have other security requirements. You need to figure out a way to ride the enterprise and internet and physical backhaul, or you could use a express route or something like that, but you need to figure out how to ride that backhaul. And then you also need to identify that there's that software kind of security that's in place, that VPN tunnel that was created by the application between the sensor and the application. And finally, then there's the application in the cloud. So in this example, this is the zone. The zone is the sensor or all the sensors that connect all the way up that green line to the application in the cloud. So when we think about this from that 62443 perspective, oh, it's working now. Cloud SL, those SLs at the bottom, that's tied to the process. Whatever they could impact at the bottom, that's where the SL is determined. Everything on that green line has to follow that SL. Remote connections, these are trusted paths. So this whole area is going to follow that SL. So the most highest consequence device that's deployed in that environment is going to drive all of that zone's security level. Enterprise connections, they don't have to follow the security level target. This is actually a type of a virtualized DMZ, you could think of it like that, but this is where that security level translation takes place. What they have to do is just provide you with a backhaul, and it is still trusted, so the concept of trust is that I trust the environment, it's still controlled, but it's untrusted. So the concept of control is I can control the environment, but I don't necessarily trust it. And the control means if I wanted to, I could unplug it, right? Because I control that environment. Once it gets up to the cloud stuff, though, it's not trusted and it's not controlled. Meaning, if it's designed correctly and there are no vulnerabilities that could get exploited, it should function the way it's supposed to, but I can't guarantee that it's going to function the way it's supposed to. And I think that's the thing we have to get behind. We're still looking at that question, right? Should we move this stuff to the cloud? And then finally, the application. We have to make sure that the application has the same security level target. So all of that is part of the zone. Can anybody see where the actual conduits are here? Do you think it's the green line between the sensor and the application? I'm just, I'm asking a rhetorical question. So the conduits here are between where the user is actually logging into a computer and connecting to the application. Because that's where there's a separate zone. That's the closest thing to a separate zone. You have to look at this entire connectivity model as a zone. So even today, we see these types of devices out there. And you could kind of argue that maybe robotics and drones are a type of controller actuator. Most of the time, we're a little hesitant in our organization, at least, to put anything in internet connected as a part of a control system in place, or maybe all the time. But we're seeing where this is happening everywhere. You have to have an infrastructure, that green infrastructure, that supports it. You've got wearables, things that are taking vital signs and locations of people, and you've got smart devices. We're looking at MetaQuest to actually augment the environment so that a field operator can see pressures and temperatures and things like that. All of these devices have to connect to something, and they have to be secured in a certain way. And if you think of something like a drone that's doing a flyover, you don't want that to obviously get compromised and get dropped or something like that, and most of the security is built in not to do that. But you might not necessarily want that in the same environment that you have something that's monitoring a pipeline. You might want those in different places. So I thought I'd put some examples there. And then the next one is the cloud SCADA model. And while we may be a little averse to this model, it does exist in multiple places and multiple industries in the field. And at a smaller scale, it probably exists in places that people don't even realize exists, to put it simply. This model looks just like the supervisory control model that I had before. The difference is all that stuff at the bottom has to somehow go through a process to connect to that same backhaul that goes to the cloud. And so normally what you see in this space is there's some kind of an I/O server, something that collects all that data that can then tie back to the SCADA application. And just like the IoT, it goes all the way back up through all the cloud. And in some cases, what you see in the market today is they'll have infrastructure as a service. Some cases it is platform-based, meaning it's containerized. And in some cases, the vendor is just offering you access to the application, which ultimately is the SCADA platform. Now you'll notice like just some basic functionality in a SCADA system gives the operator the ability to actually push a button and make some changes if they need to make some changes. So if that thing at the bottom where we said the actual security level target was set is a high consequence, then the person who's using that application that's hosted in the cloud has the potential to cause a high consequence. SCADA zone example. So I just wanted to draw this out a little bit differently. I'm going to go through it pretty quickly. SCADA zone example, it looks really similar, but you have to have a dedicated cloud to control system environment, I'll call it that, DMZ. This DMZ is very specific. It has to provide all the encryption. It's not necessarily remote access, but it is for digital identities, and it has to have robust monitoring. You have to monitor everything going in both ends and out both ends, basically, and be able to react to it. This is that one place where if you can monitor for everything from a zero trust perspective and enforce the policy, this is where you would do it. This is where you should have that zero trust model deployed, if anything. And then it goes back all the way up. Two types of encryption here. So I showed you that the tunnel's encrypted and then the software tunnel's encrypted. That first type is what we would call a gateway. So because I know not everybody's a cloud architect, the gateway is actually just the encryption of the network connection. And so even though it does traverse other networks, just the network connection, the VPN is software encryption for the application. So every zone in this example has that type of encryption. And then ultimately, the SCADA application. Just like the IoT model or the cloud sensor model that I called it, just so it wasn't confused with an actuator model. These are the two endpoints that the user knows about. The user only knows about this. They know that there's a process going on, and that there's an application that I log into. And if everything works out properly, it should look exactly the same in their control room that their current system does today. And so the conduit, again, is between the application and whatever endpoint they're using to log in and do their stuff, right? The HMI, or the application server, all that stuff could be hosted in the cloud, and they could just have a remote access client that connects to the cloud. Same thing. We can't trust the enterprise connection. We can control it. So that DMZ is really important here. Monitoring and data flows and connectivity. That's what we're managing with that DMZ. Cloud connections and facilities completely untrusted. Meaning if we were to then host something else in this same platform even, remember, we need to know what both sides of the fence are doing, IT and OT. If they did have something hosted in the same place, our OT side would say, hey, that gets that security level target that our control system has. So we need to make sure we're speaking the same terms. Sorry. Some examples, so I think some of the lower risk examples where people aren't normally at, so like renewables, solar and wind farms, geothermal, things like that. But the main thing that we can look out here, and maybe some remote monitoring of critical assets that are more difficult to get to or that are mobile, like ships. The main thing to look at here is that fully integrated control room that is so appealing to a CIO or a CISO, or not a CISO if they're OT background, but to a CIO, because that integrated control room allows full control over everything. And if we could get to that point, that would be a magical world. And that's what CIOs like, right? A lot of cost savings. We can only fit 10 people in the room, right? So we don't need 10 rooms with 10 people in them each. We just cut 90 people out of the picture. That is the vision that most, I think, CIOs that have control system environments are probably looking for today. And they've probably started building that. I know we don't have this model in our company, but they probably started building that in some companies and didn't figure the security part out first. And so if you're in that position, you can use some of what I'm teaching you here today. All right, I want to summarize the security considerations real quickly. Got 3.5 minutes. 2 zone examples I gave, the IoT or the sensor zone and the SCADA zone. There's another one that's called Edge, and you're putting some of that software and containers in the Edge device, but I didn't have time to go into that. And then when we talk about should we move things into the cloud, we look at like the 62443 from an SL level, the security level, target. And just a quick reminder, I put this up here. If it's an SL1, basically you only think that you need to apply security to stop accidental attacks, right? If it's an SL2, then it's still intentional, but not like a lot of resources. So think about it, if you put it in the cloud and all the security works, and they don't have the resources to figure out an exploit, they're not gonna hijack VMs and stuff like that, right? Now SL3, if you have a system that requires an SL3, at that point they have resources and they have experience and they have funds, and then nation state actually is looking for it, and they have the means and the time, and they are persistent. I just wanted to point that out as a reminder. So which SLs support this model? Just based off of 62443 3-3 today, going through the requirements. SL1, there's no problem, meaning as much security as the cloud has to offer, SL1, not a problem. You probably don't even need to apply all the security, right? We start running into an issue with SL2, and definitely with 3 and 4, because the one thing we can't do is guarantee physical segmentation. There's no way you can guarantee physical segmentation in this environment. SL3 and 4, it starts to get really bad at that point, because there's the concept of causing a distributed denial of service. Somebody attacks your control system on premises, and then they have access to the cloud. What do they do? The other applications and all that kind of stuff. And so that does not bode well and meet the standards requirements. So my original question, should we move it? I can kind of fall back on, if it's an SL1, it's almost a no-brainer. We don't really have to put a lot of risk-based discussion and analysis into it. But if it's SL2, then we have to make exceptions, right? Because the standard says you can't move it if it's an SL2. Now, I think that's going to also cause some reevaluation. And one of the reasons I think this is not just because it's across the board. It's going to break everything across the board as far as how the models work and how the upgrades work. But it's also because if you look at like ISA Secure, the certification for 62443 for components and control systems devices, there are a couple of edge devices on there already, and it's very difficult to get the SL2 certification. And the reason it is because you can't guarantee physical isolation. So I see it I don't see a future where there's going to be cloud services that are going through that certification anytime soon. I want to leave it at this. I'm going to save some time for some questions. All of the stuff that you're looking at on this slide that happened already, that stuff's not even in the picture. If you're looking at security for that stuff, then you're wasting your time. It should already be done. What the IT department and the company is doing is they're looking at this stuff. They want to see how they can deploy this stuff. So the other stuff's important. You can't forget it, but that's not the challenge. Those challenges they've already been solved. This is the stuff we need to focus on. So because the standards are a little slow, and I do help with some of them, and I'm not going to complain about that. Regulation's kind of slow, and it's all over the place, depending on what country or where you live. I just thought I'd put together some basic guidelines here. And I'm a sci-fi guy, so don't make fun of me. But I read Robot Dreams and stuff when I was a kid, and I think the 3 rules to robotics from Asimov are pretty good. So they're not exactly the same, but the first rule goes like a robot should never harm a human. The second one is a robot should always follow his orders unless it breaks the first rule. And the third one is the robot should never hurt itself unless it doesn't follow orders or unless it violates the first rule. So this is just simplified. If you're thinking about a technology advancement, it basically works like it should not introduce additional safety risks. It should not introduce additional operational or reliability issues. And if you have to modify it so it does meet the operational requirements, it should then not also introduce safety risks. And finally, it should not introduce additional technology risks, meaning could operate, could be awesome, could be fantastic, but if it's not a great technology, it should not be considered as part of the solution. And ultimately, everyone is kind of prioritized from that sense. I'm going to open it up to some questions. I have about 4 minutes if anybody has any questions. I do love presenting on Thursday afternoon because this time we have tens of people, but I've seen ones before, so this is pretty good. If anybody has any questions, go ahead, or else I'll shut up and we can all go about our day.
If you do have a question, please walk up to the microphone.
I have a taker, a coworker. Perfect.
Yeah. So I don't know the answer, so I'm asking an open question. So as you state, the wave is coming whether we want it or not, right? That last state is going to be the future, one way or the other.
Yeah.
So where's the best place to focus first? Is it the standards? Is it the cloud providers? Is it inside? Like, where do we begin?
I think that is an excellent question. And so I'm going to go back in time to my presentations over the years. And I started with identifying what the difference between OT and IT was, right? Most organizations struggle with this because there are so many technologies in the space. Really, a control system's a controller. Like, that's something different. But a lot of organizations don't adopt that. So starting with being able to be decisive, we'll use a good word, and decide what is OT versus IT. And it's not even a technical discussion. It's an authorization, it's functional authority discussion. That's where I would start. The next thing is, it's not an inventory. I think static inventories are ridiculous, honestly, because they're never right. But it's a process for identifying what's on your network, and it could use automated tools, detection, all that kind of stuff, and determining what your zones actually are today, your current environment. If things need to be changed or things need to be modified, or if you have additional risks, all that's part of that process. And I've talked about using MITRE ATT&CK and doing threat modeling and all that kind of stuff in the past. But it would be making the decision about what IT is versus OT, getting a good understanding of your environment, putting the functional authorities in place so that those decisions can be upheld, which we all struggle with that. And then finally it is, based off of those rules, decide what can be moved into the cloud. Don't add safety risks. Don't add operational reliability risks. There's no compromise on those. And don't add additional technology risks. So that's the storyline. Oh, and I see another question.
Howdy. So imagine that we expect that some of these standards are going to continue to develop, or at least best practices for OT security are going to continue to develop. Do you see some additional auditing standards or requirements coming onto the cloud providers to allow them to be trusted to an extent that you're willing to run some of these functions on their infrastructure, where they basically control it? It's a different story from zero trust networking, where the concept was basically I don't need to trust the network, like you showed, untrusted infrastructure. Fundamentally, would you feel comfortable running this on attacker-controlled cloud infrastructure? And if not, what needs to happen in, say, 62443 so that the cloud provider can give you enough assurance that you're willing to run some of these more critical functions with applications running on their infrastructure.
Okay. I'm going to try to summarize that. It's really long and a really detailed question, and I didn't hear all of it, but maybe I'll answer the question I want to answer. So, the cloud environment is something that you can secure. You have to build it in a way that it's controllable. And if another service provider wants to give you access to their software as a service, you need to have a channel for that connection. This can be managed through management groups where you collect resources, subscriptions, resource groups. You can manage a resource group to network devices. You can manage a resource group to whatever technology you want. So I would say current cloud providers that are supported by common benchmarks like CIS, which includes Azure, AWS, Google Cloud, and Oracle Cloud, are probably a good place to start. The easiest one, as far as a security standpoint, is probably Azure, because CIS has already done the mapping to MITRE. That's a good place to start. It will tell you how to secure the cloud environment. And just one more note, when you're talking to the cloud provider, whenever we have a partnership, so it's a little bit easier for us to have the conversation, but whenever you're talking about those solutions that you're working on together, always go through the secure by design process. And a lot of times they will say they have a secure by design process, and this is what my team does, we challenge it. We look at the architecture, we look at the inventory, we look at the components, and then we say, prove it. And if we don't feel like they've proved it, we help them design it so that it does meet our requirements.
Yeah, thank you. And I think you did answer my question, which is basically, like, with Zero Trust networking, you really can just not care about the network because you've got a secure tunnel from something you trust to something else you trust. And you really, with the cloud provider, they have to prove it to you that you should be trusting them.
Yeah, we'll leave it like that. I'm over on time. Thanks, everybody. I appreciate it.